In this demonstration, I'm going to demonstrate filtering, writing queries, uh, doing aggregations with group by and aggregations with min, max, sum sort of operations for each group for a Pandas data frame. So I'm starting with the same data set that I'd used for the previous video where I was doing for charting. So I'll just run the notebook. So this is the same housing sales data set. I load the data. I look at the top 5 rows. So we're going to be interested in probably price, zip code. A lot of my grouping aggregation will be based on zip code. But you can also then write your own code to maybe group by square feet living, square foot lot, or bathroom number of bedrooms. So for exploratory data, I use describe, which gives me mean, standard deviation, and other computed values. I just print them as integers because I don't need to see the floating point values. So you for something like year renovated, these values mean standard deviation make no sense at all, so you ignore them for the year renovated. Standard deviation makes no sense for the year built also, but we can see min year and max year 1900 and 2015. And again for zip code, standard deviation mean make no sense. So I like in the previous video I find out which is the most commonly occurring value for each of these attributes. So the most commonly occurring zip code is 98023. The most commonly occurring price is 300,000. The sales range from 2nd May 2014 to 14th May 2015. This is the same data set. Now we know that 98023 is a mode, which means it's the most frequently occurring zip code in this data set. But how many rows does it appear in? So how many houses were sold in 98023? If you run a filter like this, if you run a query like this, what it returns is a series of trues and false. So you can't do a count against them. You have to sum the number of trues that it returns. So that's why I use sum, not count here. For every row, for example, for the first row here, it checks whether the zip code is 98023. It's not, so it returns a false. For the second row, it's not, so it returns a false, and so on. So that is why I do a sum to just count the number of trues where this condition is true. Now we know that there are 342 rows or 342 houses sold in this zip code. So now my first example of using filtering. You can write a filter as if it is a variable. So this is a variable called filter excluding 98023, which I will be using in my data frame. And the filter condition is housing price zip code is not equal to 98023. So this becomes my filter condition. Now here one way you can do it is you create a new data frame. So this is a new data frame called non 98023 HPDF, where I take the housing prices data frame, and then within the data frame I just specify the filter, which means I want all the columns, and I will apply this filter to the data frame, but the filter is where zip code is not equal to 98023. Okay. So I run this code and I get 4228 rows, which is correct. Out of 4570 rows, 342 are for zip code 98023. So I should be getting 4228 rows and the same 12 columns. That's one way you can filter. You write a filter as if it's a variable and then specify. Another way is you can write a query. So you just say data frame dot query, and you put your query as if you are writing an SQL query. Zip code is not equal to 98023. Now here again I'm just creating a new data frame for simplicity, and again I get the same number of rows. Now this was a filter with one predicate. I want to run a filter with two predicates or more predicates. So this is a multi-predicate filter. I say bedrooms is not equal to 0 and square feet living is equal to bedrooms is equal to 0 and square feet living is equal to 290. I want to find all those rows where this condition and this condition are met. Now this will return trues, this will return trues. So I use a bitwise AND here. And now instead of creating a new data frame, I just apply this filter to the data frame. And for ease of viewing, I just print only the first 5 rows that are being written. So I say head 5. Okay, it seems there's only one row in any case, so it doesn't matter whether I want head 5 or head 1. So there's only one row which matches this condition. I can do the same query again as if it's a query. I specify data frame name and then dot query, and I put the query in quotation marks as if it is an SQL query, and I get the same row. This is row number 1974 in the data set. Do we want to see that? I mean, it should not matter, but if you want, we can look at that. 1974. Should be this one. Sorry, this is minimize this. And what are we looking for? Yeah, it is 1976 because 1974, the index starts with 0 and the first row in this Excel in the CSV file is the header row. So 1974 becomes 1976. This is the correct row. 142, 0 bedrooms, and square feet living condition was 290, 20875, which is correct. 290, 20875. There's only one row which matches these conditions. So that's how you can write a filter, apply the filter to your data frame, or you can use query, data frame dot query, and write a query as if it is an SQL query, but you just put that into double quotation marks. Now I want to find out how many zip codes exist in this data set. So I can use unique, and what unique returns here is it returns a numpy array. Okay, this returns a numpy array. So I want to get the number of elements in the array. For a numpy array I use size. So this is 61 distinct zip codes in this data set. Now I can set up, remember when you display your rows, if you have more than a certain number of rows, it will show the first 5 rows and the last 5 rows with ellipses in between. But you can set an option in Pandas, so say max rows is whatever value you want. So for the time I'm going to set it to 64, but I will not see 64 rows in all the outputs. We will use this feature later. So now so far we looked at filter, okay, like this or like this, single predicate filter, multi predicate filter. You create a new data frame or you apply the filter directly to the data frame. Then we also looked at the query syntax, single predicate query, multi predicate query, applied to the data frame. So now we look at group by. So we've done filtering, we've done query. Now we're going to do group by and aggregation. So I first group by zip code. When I specify count, it just shows me the count of rows in each of these attributes, in each of these columns. So which means that 98001 has 257 rows. So you can just ignore all of these values for the other columns. 98001 is 257, 98002 is 184, and so on. Okay. If for example we know that 98023 is the one with the maximum number of rows, if we had set our heading to a larger value, for example let me just set it to 25 maybe, and then I scroll down to 98023, and there we see 98023 has 342 rows, right, which is correct. We saw that earlier also. 342 rows is okay. This screen doesn't refresh quickly, but we saw that 98023 has 342 rows. Now I do for each of these column attributes, okay, I want to find what is the minimum value. So I'm going to just print the first, okay, instead of 5 rows I'll just show you the first 10 rows. Again, by default, since I'm grouping by zip code, it is ordered by zip code as well. So the minimum date in 98001 is this, the minimum date in 98014 is this, the minimum price for 98001 is 100,000, the minimum price for 98014 is 80,000, and so on. So you can see all of these minimum values for each of these attributes. Then look at the maximum values for each of these attributes. Group by zip code, show me the max for each attribute. So there are a number of zip codes where we know that there's rows where price is 300,000. So these are the zip codes. There could be more. I mean, because I'm just showing you only the head. Okay, these are the 3 zip codes where the price is 300,000, and these are for 6-bedroom houses. Now I want to compute the average. So this was minimum, this was maximum for each attribute. I want to compute the mean. Now to compute the mean, I will exclude date because I cannot compute mean of date. I could compute mode, but I cannot compute mean of date because this is a string. So I use this iloc syntax. Say I want all the rows by I want only columns 1 to 12, meaning I exclude column 0, date, 1 to 12. The 12th column is zip code. So I take all the columns, group by zip code, compute the mean for all the columns, print the mean as an integer only, and show me only the 10 rows. Again, this is a group by zip code, so the ordering is by default by zip code. So this was the max price, okay, and these are the average prices. So here we see mean prices, average prices, and I just because mean will get computed to decimal places, I just convert it back to integers. So these are the average prices in each of the zip codes, and I'm showing for 10 rows. So you can always keep changing head to see how many rows you want. If the first 5 rows are not interesting, increase the head, or like I set up above, you can actually change the max rows. That means it will apply everywhere. Okay, so we've looked at grouping to count, we looked at grouping to get the minimums, we go group to get the max, group to get the mean, that is the average. Now I want to group by zip code and number of prices in each zip code. So I take group by zip code, and if you see in this previous outputs, zip code appeared as the index. Let me just show you. By default in your data set, 0, 1, 2, 3, 4 are the indexes, and if I use filtering, I get the index value here. But when I do a group by, the index becomes, the zip code becomes the index, which I might not want sometimes. So in this example, all these examples, zip code became the index and it was ordered by zip code. Now in this code, although I'm going to do group by zip code, sorry, not here, although I'm going to group by zip code, I will say I do not want the zip code to be the index. Then I want to get the price also. Basically I'm getting any one column from this data set, and then I want to count, okay, and then I want to print the first 10. So I'll run this here. So again, I have not specified an order by, that is a sort clause, so it is always by order by zip code. So zip code 9801 has 257 rows. I just use price, but doesn't matter. I could have used any column. I wanted to get a data frame. That is why I specified a column here. What it returned is a data frame and with the index properly being reset. Okay. So that means group by zip code without using a default index, not zip code, and count the number of entries in each zip code. So 9800 257 entries. Now I want to sort. So I use the same syntax here, count, but then I sort by the second attribute. And this is where I get, yes, what I wanted to know is 98023 is a zip code with the most number of rows. Again, I use price just as an example to get a data frame. 98023 is the zip code with 342 entries 98042 is 296. And now the advantage of using as index false is I actually get an index into the entries that would have been returned if I did not do a sort. Okay, 98001, remember, if you group by zip code, the first zip code is 98001, that is index entry 0. 98002 is index entry 1. So the index entry does not get resorted, but the output is resorted. So that's how I use group by zip code. Don't use zip code as an index. Give me a column to return a data frame, count the number of entries, and then sort by that column. Now, for the total value of prices, I don't want to count the number of prices, I want to get the total value of prices. So first, in this, I'll just show you, for example, why I keep saying I want price and a data frame. I'll just show you here. For example, I get a data frame. When I say group by, like here, group by, and specify another column, group by as index, another column price here, and then any aggregation function, what it returns is, because I have group by and a column, I get a data frame. Okay. Now we'll just do this code. I group by zip code, get the price for each zip code, but I will sum the price. I will not sum the zip codes. For each zip code, what is the total price? So this is what I get, the total price for each zip code. Remember, zip code 9801 has 257 rows, but the total price of those 257 rows, let me just redo this to head 5 so that I don't have to scroll back and forth. Okay, so 98001 has 257 rows, and the total price of those 257 rows is 5,959,462,000. So there's a sum of the prices. Then, and here I did not give a head or tail, so what I got is all the zip codes from 0 to 60, that is 61 different zip codes, and these are not sorted by price, these are sorted by zip code again. Okay, here I did a sort by price. Here I'm because I just were doing a count, here I'm doing a sum of the price, but then I'm reverting to sort by zip code. Now here I take the same I do the sum of the price, but then I sort by the summed price, and I run this. So now 98023 is the one with the greatest aggregate sale price. 98042, which would have been the 22nd zip code, has the second greatest aggregate sale price. And now I can do the average of the prices. Instead of sum, I change it to mean. I don't want floating point numbers, decimals. I just convert it to an integer, and then I sort by price and print the top 10 only. So the average price in 9807 is only 295,000. So I don't see all the rows here because I'm printing only head 10. If I take out head 10 again, because I set the max rows earlier, I get all 61 zip codes. So 98023, for example, where is it? It would not be appear here ordered by zip code. It's ordered by average price. If I take out the head 10 here, I can see here 98023 is the one with the total aggregate price, but the average price for 98023 may not be the same. So, for example, 98023 is index 11 when order group by zip code, so I can look for index 11, or I can look for 98023, and here it is 98023. The average price is low. Because why is that low? Because although the total number is 80,983,000, the number of houses sold was also very high, so the average price is not very high. So if you want to find a zip code with the maximum total value, yes, 98023. But if I find the zip code with the maximum, with the highest average price, is 98007. So these are different ways you can use filters. So you can write a filter as if it's a variable and create a new data frame by applying a filter to your existing data frame, or you can apply a filter directly into your data frame. And a filter can be a multi-predicate filter. If you have multiple predicates, each of these return true or false, so use a bitwise AND here. If you don't want to use filter, you want to use SQL type query syntax, you can specify a query here directly against the data frame and either create a new data frame, or in this case I have a multi-predicate query. This query and this, now this is a SQL type syntax, so I use AND, English language, SQL language, and I run the query here. I could, for example, let me just say housing prices df dot query. I say zip code equal to, what do I want, 98001. Sorry, what was that? Yeah, equal to, and here I get 98001 and I get a 257 rows for 98001, right? We know that. Or I go for 98023, right? I run a query and I get 342 rows, or I can say and price less than 250,000. So, and then close the quote mark. So, take out. So this I can write a query as if it is an SQL query, and I get 169 rows. So this is how you can actually write queries, build up your analysis of your data set. So this was filters, this was queries, and this is grouping. You group by zip code and you count the number of rows for each zip code. Let me just revert this to head 10 and run it again. So for each zip, for 9801 there's 257 rows and so on, but of course count doesn't make sense for these attributes, it's just number of rows. But I can use minimum for each of these attributes and I get the minimum date, minimum price, the minimum year billed, the minimum bedrooms in each zip code. I can get the maximum, I can get the mean. For this I used columns because I want to exclude the date, and I know year renovated doesn't make sense. Another thing you can do with a group by is then you can just count the number of entries. I don't want all the columns, I just want to count the number of entries for each zip code. Okay, and if I set index is equal to false, then the zip code does not become the index. I revert to the original indexing scheme. I can group by zip code and then count and sort here. I can group by zip code and sum the second column in my data frame. So I get the sum of the prices. I can group by zip code. This is all 61 rows. I can group by zip code, get the price, sum the price, and then sort by the price, and then I'll just put a head. So the zip codes with the largest total value is this. Group by zip code, get price, sum the price, sort by this price column, by the summed price. Remember, this becomes sort by the summed price. Then I can get the average price. Again, I just, for simplicity, I'll just say head 10, and I can get the average price. So this is a way you can filter, you can query, you can group by, and you can aggregate in a Pandas data frame. All you need is to import Pandas and NumPy. Thank you.